These are your notes for Unit 7, Day 5 of Algebra 1. If you would like to see the warm-up, the review question, or any homework questions we covered in class today, just look at the finished notes. So today we are going to use our idea of factoring quadratics, factoring our x squared plus bx plus c, or factoring our ax squared plus bx plus c, in order to solve equations. And then we're going to use what we solved for to be able to graph parabolas, so those U-shaped graphs. So quadratic equations. An equation is a quadratic equation if the degree is equal to 2. And remember, the degree is the highest exponent. So if your degree is 2, or you have an x squared and that's the highest degree, then we call that a quadratic equation. So in standard form, you can have x squared plus bx plus c, and then it has to be an equation, so it's going to equal 0. So what we're going to want to have happen to solve these is we're going to want one side to be equal to 0. Or you could have the ax squared plus bx plus c is equal to 0. And those are quadratic equations in standard form. What we're going to do to solve these, step 1 is you want to get one side to equal 0. So you want one side of your equation is going to equal 0. Then step 2 is you're going to factor. And then step 3 is you're going to set each factor equal to 0 and solve. That's using what we're about to talk about. That's the zero product property. So again, when we want to solve quadratic equations, our steps are going to be, you need to get one side of the equation to equal 0, so you might have to move some terms. Step 2 is you're going to factor, like we've been factoring in this unit. And then step 3 is you're going to set each of those factors equal to 0 and then solve. So the zero product property is that property that we're going to use in step 3. The zero product property says that if you multiply two terms together, so like 3 times x, and the answer is 0, it's telling you that one of the terms, or at least one of the terms that you are multiplying, have to be 0. So that means that either 3 is equal to 0 or x is equal to 0 for that to be a true statement. Well, 3 can't equal 0, so that means that x is equal to 0. Or if you had, and a different example, if we had like a times b is equal to 0, then that's telling you that either a has to equal 0 or b has to equal 0 for that to be a true statement, right? If you multiply two terms together and you get 0, one of those two terms has to be 0, and that's the zero product property. So for instance, if we wanted to solve 3x is equal to 0, well, normally we would just solve for x by dividing both sides by 3, and 0 divided by 3 is 0. In number 2, we have x times y is equal to 0. So that means that one of those two pieces that we were multiplying has to be 0. So that means either x has to be 0 or y has to be 0. So those are your possible solutions to that equation. Either x is 0 or y is 0. In number 3, we have x times x minus 4 is equal to 0. So I'm taking x times x minus 4, I'm getting 0. So I'm multiplying two pieces together and I'm getting 0. So that means either the x out in front is equal to 0 or the x minus 4 has to equal 0. Well, x equals to 0 is already solved. X minus 4 is equal to 0. We would have to solve after that step. And so we would add 4 to both sides. And so my two possible solutions for number 3 is either x is equal to 0 or x is equal to 4. On number 4, again, I'm multiplying two pieces together. I'm taking x plus 5 times 3x minus 1, and I'm getting 0. Since I'm multiplying two pieces together to get 0, one of those two pieces has to be equal to 0. So either x plus 5 is equal to 0 or 3x minus 1 is equal to 0. And then we would solve both of these. subtract 5 from both sides, and either x is equal to -5, or add the 1 and divide by the 3, and x has to equal 1/3. So your two possible answers for number 4 are either x is equal to -5 or x is equal to positive 1/3. So now, what if the original problem looks like these? X squared plus 6x plus 8 equals 0, or one of the other ones. Now we're going to use those 3 steps. So the first step is make sure that you want one side to equal 0. So you want one side to equal 0. Then step 2 is factor. And then step 3 is you set each factor equal to 0 and solve. So in number 1, x squared plus 6x plus 8 equals 0. One side equals 0, so we're good. And now we factor. So to factor x squared plus 6x plus 8, we need two numbers. When I multiply them together, I get positive 8. And when I add them together, I get positive 6. So that would be 4 and 2. So I get x plus 4 times x plus 2 is equal to 0. Now it becomes a zero product property problem. Since I have x plus 4 times x plus 2 is equal to 0, one of those two factors has to be equal to 0. So either x plus 4 is equal to 0 or x plus 2 is equal to 0. We solve both of those. So subtract the 4 and subtract the 4. So either x is equal to -4 or subtract the 2, x is equal to -2. So those are your two possible answers for number 1. Number 2, remember the 3 steps. Make sure one side equals 0 first. It does. And then we factor. So y squared minus 9y plus 20. To factor that, we need two numbers. When you multiply them, you get positive 20. And when you add them together, you get -9. So what times what is 20? And when you add them together, you get -9. This would be y minus 5 times y minus 4. -5 times -4 is positive 20. And -5 times -4 is positive 20. And -5 plus -4 is -9. So now step 3, set each of those equal to 0 and solve. So either y minus 5 is equal to 0 or y minus 4 is equal to 0. Add the 5 to both sides. And so y is either equal to 5 or add the 4 to both sides, or y is equal to 4. And so those are your two solutions for number 2. On number 3, m squared minus m minus 42 is equal to 0. Step 1 is okay because it's equal to 0. So now factor. I need two numbers. When I multiply them, I get -42. And when I add them, I get -1. So this would be m minus 7 times m plus 6 is equal to 0. -7 times positive 6 is -42. -7 plus 6 is -1. So now either m minus 7 is equal to 0 or m plus 6 is equal to 0. So your two possible solutions are m equals positive 7 or m equals -6. 4, 3x squared minus 6x is equal to 0. Step 1 is okay because it's equal to 0. Now we look for the common factor, 3x squared minus 6x. Their common factor is 3x, so I'm going to undistribute or factor out the 3x, and you're left with x minus 2. So now I have 3x times x minus 2 is equal to 0. So now step 3 says to set each of those equal to 0. So either 3x is equal to 0 or x minus 2 is equal to 0. Divide both sides by 3, and either x is equal to 0 or add the 2. X is equal to positive 2. So those are your two possible solutions for number 4, 0 or positive 2. All right, let's look at some that are a little bit different. So 3x squared plus 8x plus 4 is equal to 0. Step 1 is good. It's equal to 0. But now it's an ax squared plus bx plus c problem. So remember on this, you take the a term times the c term first. And so we have two numbers that when I multiply them, I get 12. And when I add them, I get 8. So what multiplies to 12 and adds to 8? That would be 6 and 2. So we can factor by grouping. I can break up that middle term, and I would get 3x squared plus 6x plus 2x plus 4 is equal to 0. And then group the first two, group the second two, plus in the middle. And I can factor out a 3x, and I would have x plus 2. And I can factor out a 2, and I'd have x plus 2. Both of them have an x plus 2, so I can factor out the x plus 2, and I'd have the 3x plus 2 left, and then equals 0. Now we can use the zero product property and set each factor equal to 0. So either x plus 2 is equal to 0, or 3x plus 2 is equal to 0, and then solve both of these. So either x is equal to negative 2, or subtract the 2 and divide by the 3, and x is equal to negative 2/3. So your two possible solutions for number 1 are x is equal to negative 2 or x is equal to negative 2/3. All right, number 2, remember the first step is that the equation has to equal 0. Well, right now it equals 6. So to make this equal 0, we're going to subtract the 6 from both sides first. And then I would have 2x squared minus 6x, then minus 6. None of those are like terms, so I can't combine any of them. And now we're going to do the exact same thing that we did in question 1. So we'll take the a times the c. So 2 times negative 6 is negative 12. So I want to find two numbers that multiply to negative 12 and add to negative 1. That would be negative 4 and positive 3. So I'll break up that middle term. So I'll have 2x squared minus 4x plus 3x minus 6 is equal to 0. Group the first two, group the second two, plus sign in the middle. And we would get 2x and then x minus 2 plus 3 times x minus 2 equals 0. They have an x minus 2 in common, so factor that out. So x minus 2 times 2x plus 3 is equal to 0. Now the zero product property says set each of those equal to 0. So either x minus 2 is equal to 0 or 2x plus 3 is equal to 0. Add the 2, add the 2. And so one solution is x is equal to 2. Subtract the 3, 2x equals negative 3. Divide by 2, and my other solution is x is equal to negative 3/2. So my two possible answers for number 2 are x is equal to 2 or x is equal to negative 3/2. All right, let's look at the next one. 9x squared minus 24x equals negative 16. So the first step is we would want it to equal 0 first. So add the 16 and add the 16. So we would get 9x squared minus 24x plus 16 is equal to 0. This could be a perfect square trinomial because we have the 3x times the 3x and the 4 times the 4. And so if we did 3x, and since that's I need a positive 16 and a negative 24, if I did 3x minus 4 times 3x minus 4 equals 0, let's see if that worked. 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. Negative 4 times 3x is negative 12x. And when I combine those, I get negative 24x. So that worked. Or we could do the a times the c and then break up the middle term just like we did before. And we'd end up with 3x minus 4 and 3x minus 4. So if I set these both equal to 0 and solve, I would get x equals 4/3 or x equals 4/3. I get the same solution twice. We call that a double root. So if you get the same solution twice, we call it a double root. All right, on number 4, we have x times, in parentheses, 3x plus 7 equals 6. It doesn't equal 0, so our first step is we got to get it to equal 0, so we're going to subtract 6 from both sides. So I have x times 3x plus 7, then minus 6 equals 0. This is not a product right now because I'm subtracting, so I'm actually going to have to distribute on this problem and then combine any like terms. So I end up with 3x squared plus 7x minus 6 is equal to 0. Okay, well now we have a trinomial. So we're going to take the a times the c, which is negative 18. So I need two numbers. When I multiply them, I get negative 18. And when I add them, I get 7. So this is going to be positive 9 and negative 2. So let's break up that middle term. So we have 3x squared plus 9x minus 2x minus 6 equals 0. Group the first, group the second, plus sign in the middle. Pull out a 3x, and we have x plus 3. Pull out the negative 2, and you have x plus 3. They have an x plus 3 in common, so factor that out. And then you have 3x minus 2 is equal to 0. So either x plus 3 is equal to 0 or 3x minus 2 is equal to 0. And when you go to solve these, either x is going to equal negative 3 or add the 2 and divide by 3, x is going to equal 2/3. All right, let's try the next one. 3x minus 2 times 2x plus 5 is equal to 0, or we're equal to 0. I already have something times something is equal to 0, so I'm going to set those two equal to 0. So either 3x minus 2 is equal to 0, or 2x plus 5 is equal to 0, and then solve both of those. So add the 2, 3x equals 2, divide by 3, x is going to equal 2/3, or subtract the 5, 2x equals negative 5, divide by 2, x is going to equal negative 5/2. On number 2, it doesn't equal 0, so my first step will be to subtract the 32 and subtract the 32. So I have v squared minus 4v minus 32 equals 0. Now factor. Can you multiply to negative 32 and add to negative 4? Yes, negative 8 and positive 4, so v minus 8 times v plus 4 equals 0. So either v minus 8 equals 0 or v plus 4 equals 0. So my two answers are v equals 8 or v equals negative 4. On number 3, we have negative 2x squared minus 4x plus 30 is equal to 0. They're all divisible by 2, so I'm going to factor out a negative 2 this time. And if I factor out a negative 2, I would get x squared plus 2x minus 15 equals 0. And now can we factor that inside? Can you multiply to negative 15 and add to positive 2? It would be positive 5 and negative 3. So I have negative 2 times x plus 5 times x minus 3 equals 0. So now I'm multiplying three things and I got 0. So either negative 2 equals 0, x plus 5 is equal to 0, or x minus 3 is equal to 0. Well, negative 2 can't equal 0, so that won't give me any answers. X plus 5 equals 0, subtract the 5 and subtract the 5, and you would get x equals negative 5. X minus 3 equals 0, add the 3 to both sides, and you would get x equals 3. So the two possible solutions are negative 5 and positive 3. On the next one, make it equal 0 first, so add the 72 to both sides, and I would get negative 3x squared minus 6x plus 72 is equal to 0. Factor out their common factor first. They're all divisible by 3. I'm going to factor out the negative 3, and I would get x squared plus 2x and then minus 24 equals 0. So now can you multiply to negative 24 and add to 2? Yep, that would be a 6 and a 4, so it would be negative 3 and then x plus 6 and then x minus 4 equals 0. You have three terms being multiplied to get 0, so either negative 3 equals 0, x plus 6 equals 0, or x minus 4 equals 0. Negative 3 can't equal 0, so that won't give me any solutions. Subtract the 6, x equals negative 6 is a possible solution, or add the 4, and x equals positive 4 is a possible solution. All right. Let's look at the next ones. 4x to the third minus 16x equals 0. Let's pull out their common factor. The common factor is 4 and x. And so I'd be left with x squared minus 4 and then equals 0. X squared minus 4 is a difference of two squares. So this would be x times x, and this is 4 times 4, or sorry, 2 times 2. And so we're subtracting in the middle. So we would have 4x and then a difference of two squares. It'll be x plus 2 and x minus 2 equals 0. All right, now we have three terms being multiplied to get 0. So either 4x is equal to 0, x plus 2 is equal to 0, or x minus 2 is equal to 0. Now solve each of these. Divide by 4, and either x is equal to 0, subtract 2, x is equal to negative 2, or add the 2, x is equal to positive 2. So we would have three possible solutions on that example. All right, 7x to the third minus 63x equals 0. Again, pull out their common factor. The common factor would be 7x. and we'd be left with x squared minus 9 and then equals 0. X squared minus 9 is a difference of two perfect squares, so that would become 7x stays on the outside, and then we would have x plus 3, x minus 3 equals 0. We have three terms being multiplied and you get 0, so either 7x equals 0, x plus 3 equals 0, or x minus 3 equals 0. Divide by the 7, divide by the 7. One solution is x equals 0. Subtract the 3, subtract the 3. X equals negative 3 is another solution, or add the 3 and add the 3. X equals positive 3 is a third solution. So again, in number 2, you would have three different solutions. In number 3, we have 5x minus 3 times x squared plus 5x minus 45 equals 0. So we have something times something equals 0, so set them both equal to 0. So either 5x minus 3 equals 0, or x squared plus 5x minus 45 is equal to 0. To solve this one, we would add the 3, and we would get 5x equals 3. Divide by 5, divide by 5. And so one possible solution is x equals 5/3. On the other one, we're going to have to factor it. So can you multiply to negative 45 and add to positive 5? That would be x plus 9 and x minus 4 equals 0. So either x plus 9 is equal to 0 or x minus 4 is equal to 0. So your other two solutions are x equals negative 9 and x equals positive 4. On that last one, 5x to the third plus 5x squared minus 30x equals 0. Their common factor is 5x, so let's factor out the 5x, and then we'd be left with x squared plus x minus 6 equals 0. And then can we factor x squared plus x minus 6? Yep. Can you multiply to negative 6 and add to positive 1? It would be x plus 3 and x minus 2. And now set each factor equal to 0. So either 5x equals 0, x plus 3 equals 0, or x minus 2 equals 0. So your three solutions are 0, negative 3, and positive 2. And that is solving quadratic or polynomial equations. So what do we even use this idea of solving quadratic or polynomial equations? Well, if you were to graph, so if we had something like y equals x squared plus bx plus c, or y equals ax squared plus bx plus c, and you wanted to graph these make parabolas. So either happy parabolas or sad parabolas. And so we got to figure out, okay, how did this happen? Well, happy parabolas are made when you have a positive x squared, and sad parabolas are made when you have a negative x squared. So looking at our three examples, we have one happy parabola and two sad parabolas. So this right here would be a happy parabola. So this parabola, I know, would have to be an x squared parabola. The parabola next door is a sad parabola, so it would be a negative x squared. And then this one next door to that is also a sad parabola, so I know it would have to be a negative x squared. Well, we've been factoring and solving. When we factor and solve, we're finding specific points on the parabola. We're finding when the y is equal to 0, right? So we're finding when 0 equals ax squared plus bx plus c. So we're finding when y is equal to 0. When you find when y is equal to 0, you're finding the x-intercepts on the graph. And so you're finding, notice on this one, the x-intercepts are at negative 1 and positive 3. So we know that when we factored and solved, we got x equals negative 1 and x equals positive 3. You're finding the x-intercepts on the graph. On this parabola, we have x-intercepts at negative 3 and positive 1. So that's x equals negative 3 and x equals positive 1. So when we factored and solved, that's what we got as our solutions. And then here, you only got one answer. You got x is equal to positive 3. When you only get one answer, remember earlier when I was talking about a double root? That's what happens when you get a double root on these. When you're solving a quadratic function and you only get one answer twice, that's called a double root. And that means that the parabola's only going to hit the x-axis once, and it'll look like that picture. So let's find the x-intercepts or zeros of the quadratic function, and then we'll sketch a picture of the quadratic function. So we have y equals x squared minus x minus 6. So our first step is we're going to set y is equal to 0, and then we're going to factor and solve. So y is equal to 0, and then we have x squared minus x minus 6. So can we multiply to negative 6 and add to negative 1? That would be x minus 3 and x plus 2, and then solve. So either x minus 3 is equal to 0 or x plus 2 is equal to 0. So my two solutions are x equals 3 and x equals negative 2. Those are the x-intercepts of the parabola. So now if we go down to the graph, step 3 is you're going to graph the x-intercepts. So we're going to make points on the graph at negative 2 and positive 3. So those are my x-intercepts. Then step 4 is you have to decide, is it a happy parabola? So is it positive x squared? Or is it a sad parabola? Is it a negative x squared? So look at the original problem. We have positive x squared. So it's going to be a happy parabola. So all we're going to do is we're just going to sketch a happy parabola through those 2 points. It's not going to be a super accurate representation of the parabola because we're not finding this point right here, which is called the vertex. We're going to learn how to find the vertex later. But for right now, we're just going to leave it like that. And so that would be a sketch of that parabola, that quadratic function. So let's look at number 2, y equals negative 3x squared plus 3. So the first step, let y be 0. So 0 equals negative 3x squared plus 3. And then step 2 is we're going to factor. Well, what do they have in common? They have a 3. I'm going to factor out a negative 3, and then we would have x squared minus 1. And now notice x squared minus 1 is a difference of 2 perfect squared, so it'll be x plus 1 and x minus 1. So if I solve this, either negative 3 equals 0, x plus 1 equals 0, or x minus 1 equals 0. Well, negative 3 can't equal 0. So my other two solutions are x equals negative 1 and x equals positive 1. Those are going to be the x-intercepts. And so we have x-intercepts at negative 1 and positive 1. So that's where it's going to cross the x-axis. And then we have to decide, is it a sad parabola or a happy parabola? So look back at the original problem. We have negative 3x squared. Since it's a negative x squared, it'll be a sad parabola. So we're just going to make a sad parabola through those 2 points. And that's how we can sketch a picture of our parabolas. All right, let's look at 2 more examples. Y equals 3x squared minus x minus 4. So our first step is let y is equal to 0. So y equals 3x squared minus x minus 4, and then we'll factor and solve. So 3 times negative 4, so we do the a times c. So we need 2 numbers. When we multiply them, we get negative 12, and when we add them, we get negative 1. So that would be negative 4 and positive 3. So we can break up that middle term. So 0 equals 3x squared minus 4x plus 3x minus 4. Group the first 2, group the second 2, plus sign in the middle. I can factor out an x from the first 2, and I'd have 3x minus 4. The second 2, their only common factor is 1, so I can factor out a 1, and then I'd have 3x minus 4. So factor out the 3x minus 4, and then we have the x plus 1. So either 3x minus 4 is equal to 0, or x plus 1 is equal to 0. Add the 4 and divide by 3, and so x equals 4 over 3 is one of my solutions, or subtract the 1. X equals negative 1 is my other solution. Those are my x-intercepts. So negative 1, or 4/3, is 1 1/3. And then is it a happy parabola or a sad parabola? Look back at the original problem, and you have 3x squared, so that's going to be a happy parabola. So we're just going to make a happy parabola through those 2 points. All right, next one, we have y equals negative x squared plus 4. So first step, let y be 0. So 0 equals negative x squared plus 4. Both of those are perfect squares, but right now there's a plus sign in the middle. Can I rewrite it so it would be a difference? Well, it would be 4 minus x squared. And so now I have a difference of 2 perfect squares. So I've got 2 plus x and 2 minus x when I factor it. So either 2 plus x is equal to 0 or 2 minus x is equal to 0, and then solve for x. So either x is equal to negative 2 or x is equal to positive 2. So my x-intercepts are negative 2 and positive 2. Then look back at the original problem. Is it a happy parabola or a sad parabola? It's negative x squared, so it's going to be a sad parabola. So I'm just going to make a sad parabola through those 2 points. And that would be a sketch of the graph of that parabola. And so that is how we factor and solve quadratics or polynomials and what we use them for when we're graphing. Your homework is on